Hi everyone, in this video, we're diving into one of Kotlin's most convenient and powerful features, type inference. This concept is absolutely central to writing clean, concise, and modern Kotlin code. If you've programmed in other languages like Java, you'll quickly appreciate how much more enjoyable Kotlin makes variable declarations. Let's begin by understanding what type inference truly is. In many programming languages, when you declare a variable, you typically have to specify its data type explicitly. For example, in Java, you might write string name equals Alice, or int age equals 30. In Kotlin, thanks to type inference, the compiler is smart enough to automatically determine the type of a variable from the value you assign to it. This means you often don't need to explicitly declare the type yourself. The core idea is that the compiler can infer the type based on the context, specifically from the value of the expression assigned to the variable. Here, I've declared a variable name and immediately assigned it the string value ton. Notice I didn't write string after name. The Kotlin compiler looks at ton, recognizes it as a string, and automatically understands that the name is of type string. This reduces boilerplate code, making your code more concise and readable. Now, it's crucial to understand that even though we're omitting the explicit type declaration, Kotlin is still a strongly typed language. This variable name does have a type. It's string, and Kotlin will enforce that type for all future usages. As you can see, if I try to reassign the name to an integer 123, Kotlin immediately throws a compilation error. It tells me, type mismatch. Inferred type is string, but it was expected. This is where Kotlin's safety comes in. It catches potential errors at compile time, long before your application ever runs. The compiler is only able to infer the type when it has enough information, when the variable is declared and initialized on a single line. If you declare a variable without immediately assigning a value, you must explicitly specify the type. Type inference isn't just for simple strings or numbers. It's much more powerful than that. When working with numbers, Kotlin will infer the most appropriate numeric type, usually int or long for whole numbers, and double for decimal numbers. Here, my number is inferred as an int. For big number, by adding the L suffix, we tell Kotlin it's a long, and the compiler infers that type. What if you want a variable to hold values of different types throughout its lifecycle? You can still explicitly declare its type as any. The any type is the root of the Kotlin type hierarchy, similar to Java's object class. All Kotlin classes implicitly or explicitly inherit from any. Now flexible var can hold a string and later an int, because its declared type is any. Type inference also works seamlessly with function return values. If a function's return type can be determined from its expression body, you can omit the explicit return type declaration. In this example, the sum function's return type is inferred as int because a plus b results in an int. Subsequently, the result is also inferred as int. Kotlin's standard library often uses type inference to simplify common operations, like creating pairs or collections. Here, city pair is inferred as a pair string. The to keyword is an infix function that creates a pair. When creating collections, Kotlin is smart enough to find the closest common supertype if the elements are of different, but related types. For mixed list, Kotlin will infer its type as list any because string, int, and Boolean all ultimately inherit from any. Your integrated development environment, especially IntelliJ IDEA or Android Studio, works hand in hand with Kotlin's type inference. If you're ever unsure what type has been inferred, your IDE can tell you. Demonstrate in IDE. Place the caret on a variable, e.g., name, and use the show expression type shortcut. For Windows or Linux, it's usually Ctrl plus Shift plus P, and for Mac OS, Ctrl plus Shift plus P or Option plus space. This instant feedback is incredibly helpful for understanding your code without cluttering it with explicit type declarations everywhere. The Kotlin plugin in Android Studio does a great job because it knows exactly where type cannot be inferred, and then it is highlighted as an error. This allows you to see proper error messages instantly in the IDE when writing the code, without needing to compile. To recap, type inference is a cornerstone of Kotlin's design philosophy, aiming for a balance between conciseness and clarity. It allows you to omit explicit type declarations for variables and function return types when the compiler can determine them from context. It reduces boilerplate code, making your programs shorter and easier to read and maintain. Despite the omitted types, Kotlin remains a strongly typed language, enforcing type safety at compile time. It works across various scenarios, from simple variables to complex collections and function return types. Modern IDEs provide excellent support, helping you understand inferred types and catching type errors early. Embracing type inference is key to writing idiomatic Kotlin code. It's a feature that truly makes Kotlin a pleasure to work with. That wraps up our detailed look into type inference in Kotlin. In our next video, we'll dive into Kotlin's next component. So, see you guys in the next lecture.